Hello, my name is Paul Stevers, and I'm going to introduce you to an opportunity for large-scale tree seeding production powered by hydrogen for mass reforestation. This solution can be scaled globally to produce many billions of tree seedlings. At the current time, the demand for tree seedlings before 2030 is in the many billions and is expected to grow significantly. The greenhouse approach to producing seedlings has many limitations, including the production process is relatively slow, as well as relatively expensive. For example, labor is over 50% of operating expenses. The current process lacks the needed species diversity to create healthy forests. The solution to this problem is an automated indoor crop growing system, such as the vertical farm, that is powered by clean energy. A vertical farm is essentially a computer-controlled growing system that includes automated product handling and lighting. It enables multiple crop rotations and allows for customized growing environments for different species. The entire system can be powered by a new hydrogen production process that does not generate CO2 emissions. The hydrogen production facilities can be located in many existing and/or depleted oil and gas fields around the world. These facilities produce hydrogen at a low cost from these fields and leave the carbon dioxide in the ground. This provides for a continuous low-cost clean energy source for these indoor growing systems. Companies seeking to implement this hydrogen production process can purchase a license from the developer of this technology. Automated indoor growing systems are available in a range of configurations, such as the multi-level vertical farm designed by Wild and Pine from Edmonton, Alberta. Each of these can be remotely monitored and controlled. The next two slides show animated videos created by these two companies. The first one is called Hygienic Earth Energy by Proton Technologies from Calgary, Alberta in Canada. The other is the Bioprism Advanced Vertical Farm by Wild plus Pine from Edmonton, Alberta.
Just what we need, when and where it is needed. Which brings us back to the heating and extraction technologies used to produce hygienic earth energy. Many different techniques can be used to heat a hydrocarbon reservoir. One typical approach is to install oxygen injection wells and use these wells to pump oxygen-enhanced air into the reservoir. Laterals can be used to spread the oxygen over a large area. Ox injection wells are paired with one or more hygeneration wells. In this example, each hygeneration well terminates just below the cap rock. Again, laterals can be used to increase coverage. Next, a downhole membrane called a hygenerator is inserted into the heel of the hygeneration well. In this example, the membrane is a thin palladium copper alloy with multiple chambers encased in ceramic, a palladium sandwich. The ox injection and hygeneration wells can now start to work as a system. Oxygen is pumped and cycled into the lower zones of a reservoir, typically 1 or 2 kilometers underground. Combustion occurs instantly as the oxygen combines with a small percentage of the coke. This is called in situ or in-place combustion, and is a technique commonly used to warm oil and enhance oil recovery. However, hygienic earth energy is not about oil recovery. Instead, temperatures are allowed to rise much higher, above 700 degrees Celsius. A chain of chemical reactions occurs as the heat and pressure rip apart both the hydrocarbon and water molecules. Synthetic gases are produced, including masses of trapped carbon dioxide, hydrogen gas, and oxygen. The extra oxygen helps sustain the in-situ combustion. The hydrogen gas is slippery and buoyant and slowly floats upward, pooling under the cap rock. The hygeneration well then pulls the hydrogen protons to the surface, while the hygenerator excludes carbon dioxide and all the other gases, operating like a selective filter at nanometer scale. Once extracted, the pure hydrogen is stored and then distributed as a clean and green source of energy.
This is a short animation of the Bioprism Advanced Vertical Farm by Wild plus Pine. as you can see in the tray of seedlings that are moved automatically from one location to another. Once the seedlings are ready for planting, they will automatically be moved to the shipping dock for transport. This remaining segment of the video provides you with an overview of the whole building. There are several additional profitable uses for these systems. For example, if available, excess hydrogen can be sold for a wide range of uses, including transportation of products and materials. As well, hydrogen production can typically be increased as demand increases. The same indoor crop growing system that grows seedlings can also be used to grow food. There is very large demand for tree seedlings, and at the same time, there are challenges need to be considered. Countries and organizations around the world have committed to planting many billions of trees. For example, Canada has committed to planting 2 billion trees by 2030. The European Union has committed to planting 3 billion trees by 2030. As well, the U.S. chapter of an organization focused on planting 1 trillion trees called 1T.org has received pledges from other organizations to plant more than 49 billion trees by 2030. Although many seeds are currently available, more resources are needed to produce and collect the seeds needed for a full scale-up. As well, there is currently a labor shortage to plant and maintain seedlings. Therefore, this workforce will need to be expanded substantially. In conclusion, the demand for new trees is in the many billions and is growing rapidly. Hydrogen can now be produced around the world in existing or depleted gas and oil fields while leaving the CO2 in the ground. Tree seedlings can now be produced in automated indoor growing systems that can be located next to large low-cost hydrogen production facilities. Companies around the world can license hydrogen production and process and purchase indoor growing systems to grow many billions of tree seedlings. Although enough seeds are available now to supply many new indoor growing facilities, more resources are needed to acquire all the seeds needed to supply all the needed new growing facilities. Thank you for taking the time to view this video. If you're interested in more information, please visit climatesan.org/TMR. Thank you.